Okay, we're going to begin our discussion with trigonometric functions. We're going to start to think in terms of radians and in terms of, we're going to talk about Soh Cah Toa and how that relates to what we're going to be doing now. And back in geometry, when you're working on right angle trigonometry, you may have said that you may have looked at things in terms of Soh Cah Toa. For instance, if we're talking about this angle theta, the side opposite and the side adjacent and the hypotenuse, you might have used the phrase Soh Cah Toa. In other words, sine is the ratio of the opposite on the hypotenuse. Cosine is the adjacent on the hypotenuse, and tangent is the opposite on the adjacent. And that's all well and good, and that's nice to be able to reference. But if we were to take this angle and make it a central angle on the axes, we see that the opposite would be a y value, the hypotenuse or the adjacent is an x value, moving right left, and the hypotenuse is the angle, or is, excuse me, the radius along which we're spinning this angle theta. So this is our radius. So very important, I think, for your future in here, that we can get away from thinking just in terms of Soh Cah Toa and start thinking in terms of y's, r's, and x's. So sine is always y on r, cosine x on r. Cofunctions, sine and cosine are cofunctions. And what happens with cofunctions is x's and y's switch places. So tangent, y on x, cotangent, x on y. Look what happened. What was a y became an x. What was an x became a y. They're cofunctions. Cosecant, r on y. Well, secant is its cofunction, so what was a y becomes an x. You may also notice sine is the reciprocal of cosecant. Cosine is reciprocal of secant, and tangent reciprocal of cotangent. So we want to start thinking in terms of x's, y's, and r's. Okay, so we are to evaluate the sine, cosine, and tangent of this particular angle. In this case, negative 5 pi on 4, but we know that pi is 180 degrees. Pi would spin us half the way around the circle. Negative pi would spin us half the way around the circle backwards. So 5/4 pi, we could put 180 degrees in for pi and multiply that by 5 and divide 4. But what if we just think about this? It takes pi to get us to this point. And we looked at pi divided by 4. We want 5 steps backwards of 1/4 pi. So that would be 1/4, 2/4, 3/4, 4/4, 5/4. Or you could say if pi is 180, 180 on 4 is 45, 5 steps of 45 backwards. 1, 2, 3, 4, 5. Either way, we get to here and create this 45-degree reference angle. We build its triangle, and conveniently, we could call a 45, 45, 90 would have side lengths of 1, 1, and the hypotenuse √2. You probably remember that from geometry days. However, important, this one is positive, but this one is negative. It doesn't make a difference for sine, but it can certainly make a difference. So if we want sine of t, it's basically asking what is our y on r of this little reference angle right here. So we want the y is 1, on the r is √2, and if you feel compelled or required to rationalize that, √2 on 2. Cosine. For cosine of t, we get to the same place, but now we're looking for our x value on our r value, -1 on √2, or if you are compelled, excuse me, x on r, yeah, negative 1 on root 2, or you're compelled negative root 2 on 2, rationalized. And tangent y on x. Again, if you're thinking opposite adjacent, that works, but trust me on this one, there's going to be a case you're going to see soon where Soh Cah Toa will fail us. So from 45, opposite 1 on adjacent negative 1, but better yet, y on x, y1 on x negative 1 is just negative 1. So x's, y's, and r's, want to think of things in terms of those. You'll see why shortly. All right, so we're going to spin around the circle in a positive direction, 5 steps of pi on 3. Pi on 3, it's 3 steps to get to a half revolution, or you could say pi 180 degrees divided by 3, 60. 5 steps of 60 degrees. So that would be 1 step about to here, 2 steps, 3 steps, 4 steps, 5 steps right into here, and we create a 30, 60, 90. And the side lengths we use for 30, 60, 90s are 1, 2, and root 3. 1. So often I will see the 2 and the root 3 mixed up, but 2 is bigger than root 3. Square root of 3 is about 1.7. So 2 is our long side hypotenuse. This is root 3. The most common mistake now is to move on without adjusting for positives, negatives. Well, 1 is positive. Root 3, that's down. The radius value, 2, is always positive. No matter where it is, the radius is positive. So at this point, we want to find sine of this angle we've created. Sine, maybe I should write this down each time. Sine y on r. Our y value, negative root 3 on our r value, 2. Cosine of t, x on r. Our x value, 1 on our r value, 2. Remember, what do cofunctions do? They just switch y's and x's. And finally, tangent. Tangent y on x, our y value being negative root 3, our x value 1, or just negative root 3. So pretty simple. One other thing you might note for tangent, tangent, if we don't do any reducing or rationalizing, tangent will always be this on that. Why is that? Because this is our y value, that is our x value, and tangent is y on x. Lots of connections to be made. Let's take a look at another one of these. I'm going to spin around in a positive direction, 11 steps, pi on 6, 180 on 6, 30 degrees. So I need 30 degree steps. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, leaving me 30 degrees short of a full revolution. Of course, you might have noticed that 12/6 pi would have spun all the way around, and 1/6 less than that would have gotten us back there. So there might be a quicker way to do this. Okay, we are to find sine of t, cosine of t, tangent of t. So our values, short, 30, 60, 90, right triangle, short side 1, long side hypotenuse 2, and root 3, but this is negative. Okay, sine, y on r, negative 1 on 2. Cosine, x on r, root 3 on 2. I said on the last slide that if there is no rationalizing or reducing, there's tangent for you right there. Negative 1 on root 3, because this is y, this is x. So that, if you felt compelled, would be negative root 3 on 3. Of course, they're both equivalent. Evaluate all 6 trig functions. Right now, if you've been thinking, hey, I can just do all this with Soh Cah Toa, this is when you're going to find out, you know what, that doesn't always work very well for us. 3/2 pi, or 3 pi on 2, or 3 steps of pi on 2, 180 on 290, 3 steps of 90 degrees, 1 step, 2 steps, 3 steps. We don't even have a triangle. How can we Soh Cah Toa with no triangle? So we have spun around this angle to here, and that radius could be anything we want, but the most convenient choice for our radius in this case would be 1, making this the ordered pair 0, -1. Which means our x value is 0, our y value is -1, and our r value, the radius that would spin to this point, must be 1. See, we don't have an opposite, an adjacent. We don't have a hypotenuse here. So, sine of t, y on r. Y is -1 on r1. Cosine of t, x on r. X is 0 on r1. 0 on 1, 0. Tangent of t. Tangent, y on x. -1 on 0, undefined. Let's jump to cosecant x for cosecant t. Reciprocal of sine. Reciprocal of -1 on 1 is 1 on -1. That's still -1. Secant of t. Reciprocal of cosine. Reciprocal of 0 on 1, 1 on 0, undefined. And cotangent t. Reciprocal of tangent. Reciprocal of -1 on 0, 0 on -1, 0. So though I just use reciprocal properties. Honestly, if you ask me what is cotangent in terms of x's, y's, and r's, I would have to say tangent is y on x, so cotangent is x on y. I know they're reciprocals. Okay, we could go ahead and find this just by saying let's take 19 steps of pi on 6 backwards. Well, pi on 6, 180 on 6, 30. So 19 steps of 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right now you might be feeling kind of foolish, or like I'm kind of foolish. 12, 13, 14, 15, 16, oops, 12, 13, 14, 15, 16, 17, 18, 19 gets me to right here. But this says use the period as its aid, and we know that sine repeats itself every 2 pi, so we might want to think of this as sine of -12/6 pi minus 7/6 pi. That just gets us back to the same place. So sine of -6 pi, we could have just done this in 1, 2, 3, 4, 5, 6, 7 steps. Gets us a 30, 60, 90. A 1, a 2, a root 3, most common mistake, not checking, root 3 to the left. Okay, so I'm going to set this, oh, we're just finding sine. That's nice, nice break here. Sine, y on r. Look, opposite on hypotenuse, but that is just our y value on our radius that we are spinning along. Okay, so that is our sine of -19 pi on 6. No problem. Okay, now, we may have rules for this later. This time right now, we don't have rules for this, so we're going to have to just give some consideration to where might sine actually be 3/8. Well, if sine is y on r, the side lengths are in ratio 3 to 8. I notice that is positive, and since r is always positive, the only place y on r can be positive is when y is positive. It's got to be up. So y is 3 to r's 8, relatively short y. I'm going to try to draw it somewhat to scale. Maybe something like that. But that's not the only place that could happen. That could also happen over here because we are still 3 to 8 there. Okay, so -t. Now I understand t could be a negative number unto itself, and then it would rotate the normal direction. But I'm going to rotate backwards or clockwise to, let's say, this point right here. So along my rotation, I go to there, and let's say that is a rotation of t in the negative direction. Where would my rotation of t in that positive direction go? Well, this goes a little more than 180, so I would go a little more than 180, getting me a triangle right here. And this would still be 8, but this value would be negative 3. And you say, well, it appears like our solution's negative 3 for y on 8 for r. That's what sine is, y on r. But what about if it's the other triangle? Well, let's go back to our rotation of t. What if t rotates all the way around to there backwards? Where would positive t rotate us to? All the way around to right here. Still negative 3 on 8 is our y on our ratio. So sine of t, I'm convinced, must be negative 3/8 regardless where sine of t is. It's either in the third or the fourth quadrant. How about cosecant of t? I don't need any of this. I know that sine of t and cosine of t are reciprocals, so negative 8/3. So there you have it. That's kind of an introduction. We want to start to learn to think in radians, but I cannot emphasize enough how much you want to get over the Soh Cah Toa. Yes, we're still going to use Soh Cah Toa, especially on story problems, but thinking in terms of x's, y's, and r's is a very important concept in this chapter and beyond. Okay, thanks for viewing. I hope that was helpful. Good luck with your pursuits.